Hello and welcome to another video. In this video we're going to be working on sentence similarity 3. And in this one you're given two sentences which are composed of words with spaces. And then two sentences are similar if you can insert an arbitrary sentence, possibly empty, inside one of them such that they're equal. And so the basic idea is a sentence is just a list of words. And can you put in some list of words into one to make it equal to the other only at one location? So let's take a look at these examples. So here, for example, in this my Haley and my name is Haley, this is the common section. And so you can put in name is right over here and then they'll be the same. And then in the second example, this is the common section, and because you're going to need to put in this and this into this sentence, you need to put in two things, so then it doesn't work. And in the third example, these are the same, so you can just put in right now at the end. So basically there's kind of three different scenarios, and two of them are pretty easy to see what to do. So let's say we have sentence A and sentence B, where sentence A is the smaller sentence that we're inserting into. So we're inserting into A. So because we're only inserting into one location, we can either insert into the end of A. So insert into end, start, or middle. And so we can take a look at like how the end and the start work, and then we can get the middle, and then we can figure out like is there something simpler. So basically, here's an example, or actually not that example. Here's an example of inserting at the end, right? So we're inserting into this sentence. And we're basically just saying, okay, these are the same. Let's just insert everything at the end of the sentence. And how do we do that? Like, how do we check for that case? Well, we can just compare the two sentences. And if we know we're inserting into sentence 2, we can just compare words. And then if the entire sentence 2 is at the start of sentence 1, right? Like, let's say sentence 2, for example, is like A, B, C, D. And then sentence 1 happens to be like A, B, C, D, E, F, G or something. Like basically if there's a prefix match, then you take whatever you didn't put in yet and you just put that in the end, right? So you can basically just traverse the two sentences, and if they're the same at every word and you get to the end of sentence 2, then this is possible. So this is inserting into the end. So pretty simple. And we're going to break our sentences down into words. So you basically, in this case, you would just say like, okay, A's are the same, B's are the same, C's are the same, D's are the same. Now I'm done with sentence 2 and I still have sentence 1 left over. So I can just take whatever I didn't put in and put it in. And we don't need to do that. We just need to say, is it possible or not? Okay. And inserting into the start would be the case where, let's say sentence 1 is this. And now sentence 2, instead of being A, B, C, D, is D, E, F, G. Right, so we're basically inserting whatever's missing at the start, we're just inserting here. So in this case, we would insert this. So how do we check for this one? This one is also pretty easy. We can just compare backwards, right? So here we're comparing like the prefix or from the start, from left to right. And then here we compare from right to left. So for this case, if we're comparing right to left, and once again, we run out of bounds in sentence 2, so like these are the same, these are the same, these are the same, these are the same, and then we're out of bounds, then we know this is possible. So you can actually just, for one of these two cases, you can just do a for loop and compare from the start or the back. And then the last one is inserting to the middle. So if we have this thing again, and now we have something like A, F, G. Right, we're inserting into the middle. So this wouldn't actually be like A with a bunch of spaces, but it would actually look like A space F space G, just drawing it like this. And you can't do some kind of greedy, like, once things stop matching, let's just put things in, because you can have a bunch of like edge cases for that. So for example, like you can be like, well, you know, if you could say like once things stop matching, that's where you'd put in something. You don't really know how much you have to put in, because let's say this is like A, B, A, B or something. And then here, let's say we have an A and an A or something like that. Or actually, let's say we have, let's think. We want to put into the middle, right? So let's say we have AAB, I guess. like once these don't match, we don't really know what to put in, because what we actually have to put in here is we actually have to put in this. We have to put in BA, BA, B. But we can't just be like, once these don't match, let's just go through this until the letters match. Because then you'd only put it in like this. And then that wouldn't work, right? Like, because A, B, A is not the same thing. So you can't do some, like, once there's no match, do something here. But going back to this example, so this is our sentence. So we need to know, like, what we're putting in. We don't really need to know what we're putting in, but we just need to know, is it possible? So notice whenever we're putting in something into the middle, our word, like here, we're comparing at the end, and this is a perfect match. Here, we're comparing at the start, and this is a perfect match. And here, we're comparing at the start and the end, and we get a match, right? And it might look like this, but not necessarily, right? Like we don't know, like, how much of it matches. But notice, like, let's see what happens if we compare from the front. So if we compare from the front, this is a match, right? So that means that if this is a match from the front, then into the end, we need to, basically this needs to match at the end, right? So we can compare at the front and at the end. We can do both of these. And so from the front, our match would be this. And from the end, our match would be this. And then we can just check, like, did we hit the whole word? So that's kind of the idea, because when you're putting something into the middle, basically some part of this word will match the prefix and some part of it will match a suffix, right? Like, I have to have some kind of thing like this, where, like, some of it's at the end, some of it is at the front, and I'm putting into the middle. And because some of it's at the front and some of it's at the end, when I match from the end, actually in this case, when I match from the end, this whole thing will match. So that would also work as well, and that would be a solution. But I can also put in, so there's kind of like a few solutions here, right? I can put in B, A, here. Or, because the whole thing at the end matches, I can also just say, like, well, this can just go at the end, and then I'll just put in A, B at the front. But either way. So what we can do to summarize is we can compare from left to right and right to left and see, did we actually hit the whole word in either of these comparisons? And so if it's case 1, we'll hit the whole word in this comparison. If it's case 2, we'll hit the whole word in this comparison. And if it's case 3, we'll hit part of it in one, part of it in the other, but the whole word will be matched. And the way we're going to do that is we're just going to say, like, we're just going to have an index of how many characters did we match. So in this case, when we compare from the left, we're going to say, okay, we match this. So our index here will be like 1 from the left. And then from the right, our index, the whole thing matches. So our index will basically be like 0. So from the right, it'll be like 0. And then we just have to check, is the left index bigger than the right? That means I matched the whole word. So that's kind of the idea, is we're going to take our sentences, break them into words to make it for easier comparison. You can do this in O of 1 space if you want to. Like, you can compare sentences directly and just write some logic for, like, looking into spaces and all that stuff. But it's just because these are pretty short, it's just easier to break them up into words and compare words. But that's essentially what you're doing. So you're basically comparing the prefix and the suffix, and you're checking, like, if I combine both of those, did I match the whole word? Because in order to insert either the front or the back or the middle, this whole word had to be a match if I do both of these comparisons combined. Okay, so let's take a look at the code for that. So the first thing I did is, if the sentences are exactly the same, we can just be done. Because they're only 100 characters, so you can just check that directly. Because then we don't have to, like, see which one's shorter and which one's longer and so on. Then we can split the first one up into letters, second one into letters. And then in my case, I always want the first one to be the one that we're inserting into. So I just said, if the first one is smaller, let's just, I guess you can do one of two ways. You can also call this function with the reverse. That would also be fine, right? So you can just say, like, return are sentences similar. And then you just swap them, right? So sentence 2, sentence 1. Like, that also is fine. Because I basically just want the first one to be shorter. Okay. Then this is going to be like our index that we're comparing from the front. And so we're basically saying, let's just compare these from the front. until there's not a match. And then let's compare them from the back. So this is from the front, we start the first word. Then this is compared from the back, we start the last word. So as long as they're equal, let's just keep going. And then just check, are my 2 pointers that I used, like, is where I started at the end, or where I ended at the end, it has to be smaller than where I started the front to go through the whole word, right? Like, basically, if we have a word like, let's just take a look at something. So let's say this is our word. We're not going to show this, but let's say this has 10 characters. So our pointer for what we covered from the front, let's say we ended here. And our pointer from what we covered from the back, right? So from the front, it's going to go this way. From the back, let's say we ended here. That means that the pointer is the last character that we weren't able to match. So if it's like this, and let's actually draw this in a different color. So this back one is going to be like this, maybe. Okay, so that means that we weren't able to match both of these, so that doesn't work. But if they're the same, that means we were able to match everything but this character, so that doesn't work. So the front one has to be past the back one, basically, in order for this to work. That means you match the whole word. Like, if the front one is at the 5, that means you matched this from the front, and so you needed to match this from the back, and in order to do that, this needs to be here. And you can have, results where, like, you match the whole word both ways or whatever, but as long as you were able to match the whole word as a combination of these two things, it's fine. Yeah, you can also use some other data structures. You can also do this with DP, or you can, I think these two are kind of intuitive, like these two cases, and then for this case, there's a lot of edge cases that I ran into that's like, maybe I'll just look for the first mismatch, and then I'll just, like, do some greedy thing there, but it doesn't work because there's a lot of, like, these things where you can't just look for the first mismatch. You actually have to compare from the front and the back instead of, like, looking for one mismatch and just seeing, like, is there only one? Yeah, I think this should be fine. Yeah, okay. So here, pretty tough problem, I think. Like, to recognize this, that you have to compare from the front and the back, and I guess it has, like, a low acceptance rate for a medium. So, and yeah, like I said, you can do a no one space instead of breaking this down into words. You can compare character by character and look for spaces. It would just be more complicated. So in this code, you would just compare character by character instead. It would just be a little bit more complicated. And then, but yeah, like I said, because the sentence is only 100, and it's, like, basically nothing. If the sentence was, like, really long, then you'd probably not want to store the whole thing. So this is linear because essentially we're comparing, so we're breaking down our sentences into words, which is linear. Then we're comparing from the front, which is linear. Then we're comparing from the back, which is linear. And anytime we find a mismatch, we break. So we're not going to have, like, an n squared. Like, anytime a word mismatches, we just break either one of these. So that's still linear. And then space. So I guess O of n is more like O of n plus m, where it's like both of these strings combined, and this is the same thing. Because we're basically taking both of them and bringing them into words. Yeah, that's going to be all for this one. Hopefully it was helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.